So again, we will continue with the session with the sir. The next session, observational study design and its a measure. So again, welcome, sir.
I'm going to share this slide.
Yes, yes.
I think it is visible.
Yes, yes, visible, sir.
So I'm fine now. With this back. So now observational study design and its measures. I made all the slides new because last time we were presenting in a different way, and now these are the different slides. So you will have two sets of my presentation. Observational study, non-experimental study. So in an observational studies, researchers, they observe individual and they record variables of interest. I told you the data needed and does not attempt to influence the response. Yes, you do not do anything, any intervention. Your effort doesn't influence the outcome. So you do not start treatment, you do not do any vaccination, anything. Means no action is required from researcher end. It is non-experimental. We call it observational. We simply observe the phenomena which is happening, but we follow a standard method. Types of observational study, like exploratory study, that is one. Now I have enumerated, I will take one by one. It is a small scale study of relatively shorter duration. Exploratory, when you do not know anything. You may recall during COVID period, whenever anybody was doing anything, any small, and if somebody gets a good response, immediately he will publish it. And at that time, all journals, they were publishing, and they used to mention that this is not pre-reviewed article published. means without being reviewed. We used to, because the time was so short, nobody knew about the new disease and people were dying such a fast, very quickly they were dying. So we had main issue that anybody XYZ, if come across any new phenomena, any observation, we wanted to circulate it. And this you have to see. You have seen during COVID period. Exploratory study in such situation you do. Any new thing happens, then you explore, which is carried out when not much is known about a situation or a problem. We call it, this is exploratory study. So that is one thing. Now, descriptive study. Descriptive study, it involves the systematic collection and presentation of data to give a clear or particular situation and can be carried out on a small or large scale. So descriptive, you have to describe in detail and you have to follow some systematic collection of data. So that is descriptive. In exploratory also, we have devised that how to do that study, but then it is open. Any method is acceptable in exploratory because you are exploring. Many times you carry out cross-sectional study and you say that it is exploratory because you do not know about that disease. And cross-sectional, you just collect, you just interview some people and then you write down. So we call it exploratory. So in descriptive, although the data description is factual, accurate and systematic, the research cannot describe what caused a situation. So here you cannot establish causal relationship, how this was caused, the causative effect, which you cannot measure in descriptive study. It does not answer questions about how, why the particular thing has happened, particular disease has happened, particular event has occurred, which is done under analytical research. We will take up under observational the analytical research. Thus, descriptive research cannot be used to create a causal relationship where one variable affects others. Like cross-sectional study is one descriptive study, you can call it. They are carried out for formulating specific hypotheses. Yes, descriptive study or exploratory studies are the first studies which is carried out to make some hypothesis. And on the basis of that hypothesis, we make another final study design for the concept so that we can make it operational and then we try to carry out that particular research. So it includes case reports, that is one, and then case series. Cross-sectional you can also say, but I will take up into third heading. In analytical you can say, but there are different classifications. You go to different books, like I have my views and I have classified in a different way. Some books I have classified in a different way. I have seen some. So anyway, I'm trying to tell you that the case reports and case series, this is very important. And in medical research, the case reports and case series are published. Many times it is not considered for promotion purpose or as a good research, but sometimes even case reports are appreciated very much. I will tell you how and why. Detailed presentation of a single case. Case report. A case report you can see in journals, British Medical Journal or other international journals, you can find there is a separate column that case reports, few case reports. I remember in 83, when I did MD, I joined a job in Jamnagar, Gujarat. I was assistant professor there. In 84, I came across a research article that there was case report that few young people, aged 4-5 young people, they were aged 30 to 36 years, they developed Kaposi sarcoma. Now, Kaposi sarcoma was only reported in old people who are about 70 years or 75. It was never reported in younger population. But in 84, 83, 81, it was first time reported in the world in some African countries. And that was published as a case report. I was going through, I was shocked. that something new disease has come, and later on we proved that it is AIDS, or we become HIV positive or other things. We came to know detailed knowledge. But in beginning, in 84, 83, very little knowledge was available. And then even I myself read with a lot of interest, what is this disease? Why 36-year-old people, they suffer from uh, unknown disease. They mentioned something new disease. They called it new disease. There was no name. Detailed presentation of a single case. So it enriches our medical literature. It enriches different doctors, different researchers, that you describe in detail every parameter. That is one thing. Generally report a new or unique finding. I told you, when there were any new thing occurs, you report for the first time. And then we take it and it is published. Previously undescribed disease, that is published. Unexpected link between diseases, yes, that is published. In my lifetime, I have came across 2 types of diseases which I was not aware, and it was something different. Like one, in a village in 92, 93, there was a Palol village near Anand district. I was in Karamsad Medical College. So some 121 villagers, they developed small joint arthritis within a period of 1 month. So in ration, they have received some new oil, eating edible oil. But later on, we came across that, yes, it was because of bite through ticks. So I was not aware of that disease. And in US, people have reported. So I thought, then I gave treatment in the line of Lyme's disease, which does not occur in India, but occurs in US. The antibiotic, penicillin and tetracycline is drug of choice, because doctors, they used to give cephalosporin and other higher antibiotics. Nobody tried for penicillin or tetracycline in 92, 93. They were giving. When I came to know the sign symptoms, then I reported that to CMO, then let us try these 2 medicines on the line of Lyme's disease. And they became all right. It was very surprising. And we were not having any facility to diagnose it, but I just guessed. So this is one thing happened in my life, that and second time, then leptospirosis. Then it is a long story. Then how we came to know that this is a case of leptospirosis. I worked there for 11 years. So it was an unknown disease. So unexpected link between it. That is a separate, I think. I may have to take 3-4 hours to describe in detail what happened, how I approached to an unknown disease, what happened. Again, interesting story. Thrilling, very thrilling. Unexpected new therapeutic effect. You are using medicine for for one disease, and all of a sudden you find that another disease is also cured. If a person is having 2 diseases and you are giving medicine for one disease and the another disease is cured, then you are shocked and surprised. Let me give you one more example. We had anti-malaria program in 1956 and 54, and before that we used to have plague epidemic. And Government of India never had any program for plague eradication or plague control. But during DDT spray of anti-malaria program, they sprayed everywhere to control, to kill mosquito. So what happened? The plague also got eradicated, you can say, or eliminated. Plague bacilli, the carrier were killed. So you read the story of malaria, you will find how it indirectly controlled plague. Otherwise, whole village used to get cleaned because of death. Thousands of people used to die. It was spreading so fast, plague. But it did not occur after spray of DDT. It continued for many years. Now we get some random cases, like in 92 in Surat, we got 64 cases of plague. And there is a confusion and fight going on whether it was a viral disease or plague disease. But the epidemiology, the investigation reported that it is showing both these, the characteristics of both the disease, having symptoms of signs presentation of plague also, and then another viral disease. It was also showing like, because some characteristics of plague, some characteristics. Those who were pathologists, or those who identified the organism, NCD, NICD, they said it is plague. And virological institutes, they said no, it is viral. So it was fight between two big institutes. So unexpected new therapeutic effect may occur. Then adverse event. Yes, now you get adverse event of due to some medicine. Then after case report, case series. As name suggests, when you have similar cases more in number in coming time. Like if you have seen few cases in August 22, August, September, then in 23 again you come across few cases, similar cases. 24 again if you come across. So after 2-3 years, then you say, okay, then you publish it in the name of case series. So experience of a group of patients with a similar diagnosis, we publish. And in case report, single case report is published. Case series, these two things are very common in medical literature, and international journal and national journal, they publish. They ask you whether it is a case report or case series. You should be very clear. Cases may be identified from a single or multiple sources, generally report on new or unique condition, and it is useful for studying predictive symptom sign test, because you can predict if after you have observed continuously for 3 years some cases, then you can predict if similar cases occur, then we can treat. Like when we came across in 92 about that arthritis, we predicted and we gave patients the tetracycline and penicillin. There was a dramatic improvement. Those who were not given, they developed deformity. In spite of cephalosporin and other higher antibiotics, they all developed deformity of finger. Then what happened after 5 years in 97? Again, cases started appearing in the same village, Palol village. Then what happened? The medical officer of PHC, he was aware of, and from day one, he started penicillin to the children, less than 14-year-old children, and to adult tetracycline capsule. And none of them developed any deformity. So here, what I say, studying predictive symptoms. So they could predict, okay, let us give, because we have given medicine in 92, 93, then it occurred in 97 after 5 years. I followed till 2008, but then later on, no one reported. Otherwise, because I was in Surat, so whether I remained ignorant, that could be one possibility. But I was continuously in touch with our Karamchand Medical College. I used to phone them. I used to ask them, have you come across any case of arthritis later on? So this study helped. The case series, you can say, similar cases, group of cases, predictive symptoms, and then treatment. Creating case definitions, clinical education, audit, and research, it can help you. Health services research, and you can establish safety profile. Often report rare cases for which trials may not be feasible. Now, any case, if they are very few in number, how can you do trial? Because you have only 3 cases or only 11 cases. You cannot, because then new cases you will not get. You may get after 10-15 years another set of new cases. Till that you may forget, and some new generation, new doctors, they may come across such cases. And then, so it is really very difficult. If it is irregular basis, then it is very difficult. Now, let us come to analytical study. And I am taking analytical study attempts to quantify a relationship or association between two variables, an exposure and an outcome. They are carried out for testing a specific hypothesis. I told you that the descriptive study, you develop hypothesis and then you do analytical study to prove that yes, the causative reason, what is the causative reason? Particular risk factor is responsible, or a particular exposure may lead to particular disease, whatever you can study. Study subjects can be observed currently prospectively or retrospectively. So either you observe them today, we call it in cross-sectional study, prospective, like in cohort study, or retrospective, or case control study. And then you can divide this study into like cross-sectional. Many people do not keep this cross-sectional into analytical study because you do not establish uh, causative. Causative you establish only by B and C, cohort study and case control study. Basically, cross-sectional study we can also keep in other descriptive study, like I told you, like case study, case series study, and then cross-sectional study. This could be one more classification. And then because sometimes people they try to establish some relationship. Actually, you make hypothesis. You cannot prove it. So that can be done in cross-sectional study. Let us take cross-sectional study. I will take these three in detail. Okay. So please listen it carefully. Cross-sectional. It is a study in which disease and exposure status are measured at a single point in time, same time, in a given population. That is peculiarity in cross-sectional study. Otherwise, in case control study at different time, cohort study at different time. But in cross-sectional study, simultaneously, the healthy population, unhealthy population, exposed, whether cigarette smokers, non-smokers, everybody you can ask question about their current status on that particular day of survey, whether they have any illness or any problem, that you can write down. But there will be no directionality. Directionality, I will discuss later on. There should be some direction. Here you won't get any direction. Cross-sectional studies can be thought of as providing a snapshot. Like if you all, my students, all faculty members, if you sit in lecture hall, if I take a camera and I take a photograph, then somebody may be putting hand like this, listening my lecture. Somebody may be listening like this. Somebody may be listening like this. Somebody may be listening lecture like this, or taking a sip of glass of water. What I want to say, you will get a photograph in a different postures. So we will say that at that point of time, you are sitting like that. So we call it cross-sectional study. We study at only one point of time. So this cross-sectional study, some authors, they said that it is a snapshot study. Okay. And you get frequency and characteristics of disease in a population at one particular point in time. This is very important. Now, suppose you do health checkup of a classroom. There are 100 children, and you are two researcher. You go over there. So perhaps at 9 o'clock, if you start thorough checkup, so on day one, you may carry out health checkup of 25 students. Suppose you go there from 9 to 12 after one school is closed. So you can only carry out your study from 9 to 12 only. Then next day you go for other 25 students. Third day, another 25 students. Fourth day, another 25 students. What you did, you examined each and every child at one particular time. Like one student you examined at 9 to 9:10. Another student you examined from 9:10 to 9:20. Third student you examined 9:11 to 9:30. So the student may be healthy at that time, 9 o'clock, and may suffer from disease on next day. But next day you are not going to examine him. So you will report that student was healthy. He was not having any disease on day one between 9 to 9:10. Okay. So every student you will examine for 10 different days, 10 minutes at different time and different days. But you will examine only for 10 minutes. So we also call it as a cross-sectional study. You cannot do health checkup of every student in 10 minutes. If you take with you 100 investigators, then you can examine simultaneously 100 students in 10 or 15 minutes. But then there will be variability of one person to another person that you want to check. If you keep researcher less in number, 3, 4, then and you train them thoroughly, they will follow a standard protocol and then they carry out. This is what practically possible. You cannot give employment, you cannot recruit 100 individual for 10 minutes job. At least you can recruit for 1 week or for 1 month, then they can collect data, you can enter data into computer. So you will keep. So practically it is not possible. So this is cross-sectional study. So the important point here is that particular point in time. At particular point in time, this is what you have to mention in cross-sectional study. And cross-sectional study is quick and cheap. Many times in thesis, in PhD, people go for cross-sectional study. That if you want to study the knowledge of students about HIV/AIDS, or knowledge of students about COVID vaccination, or knowledge of students about traffic rules. So you may examine 1000 students, but again, you will interview for half an hour, one student at one time, and you may continue examining 1 year. You may collect data because daily you may interview only 5 students, may not be more than. For half an hour, you may get tired. You may make a team of 2 members. You calculate how many days it will take. Going there, requesting school teacher that students, they are spared from the classroom for half an hour. One by one, you take their interview. So anyway, it is quick and cheap because you have not to do follow-up. However, since exposure and disease status are measured at the same point of time, if somebody is getting exposed, if somebody is suffering from disease, only at that point of time. It may not be possible to distinguish whether exposure preceded or followed the disease. You cannot comment. If you follow a group of people for 6 months, then you can say, yes, 10 people were exposed. Out of 2, after 6 months, they developed disease. 10 people, they were not exposed. Even then, from them, 4 or 5 people, they develop disease. This could be your observation. You can do follow-up. So you cannot say whether exposure preceded or disease preceded. And thus cause and effect relationship cannot be established. So please write down. In cross-sectional study, you cannot establish causal relationship, cause and effect relationship. That is the weakness of this cross-sectional study. Now, where do we apply this cross-sectional study? To estimate prevalence of health condition or prevalence of behavior, prevalence of risk factor or potential for disease. This is what is usually studied. I have given you only few examples. So those who are preparing their PhD topic or planning for their research, if they go for cross-sectional study, if such type of study, they can plan. It is cheap, but you collect larger sample size, then you go for long interview for 1 year or 6 months. To learn about characteristics such as knowledge, attitude, and practices of individual in a, like KP study. We do many times we do KP study. It is a type of, you can say, qualitative research. If questions are not open-ended, close-ended, then if questions are open-ended, very frequently the qualitative research people, they use this KP study, which is a cross-sectional study. You interview only once. To monitor trends over time, yes. Suppose you do health checkup of 100 school children in year 11, and then 11, 13 again you do health checkup of school children 100, then in 17 again, then in 20 again, and then you have cross-sectional status of school children for last 5 years, 5 different years. So you can see that dental caries, where the means 11, there were 20% children who had dental caries. But after 10 years, you can say that now this year you got only 11% cases of dental caries. So you can say that the trend shows in 10 years that the caries cases are declining. This is what you can, but you cannot establish. You have data from different Framingham heart study. If you have heard about that, you can see that they started somewhere in 1950. Still, they are continuing. Every 2 years, they are examining the population. And in 91, they recruited their children. In 2007, again, now their grandchildren, they have included in the study population. And now they are collecting their DNA analysis. So they are having huge bank of 5,000 population of DNA data. Now they are observing how many people are developing cardiovascular disease and how many, whether people are, the risk factor term was evolved in that Framingham Heart Study. So I refer you to go through the internet and read how the Framingham Heart Study was done and what it is a type of cross-sectional study. But they did every year. So you can't say cohort study. Actually, they followed. They are doing so. It is the largest cohort study. Sorry. It is the largest cohort study. A group of cohort they are following for last from 1950 to even today they are following. But many people have died, so their children and then now their grandchildren they are weird. So they have history that if a grandfather had the particular disease, whether their children are having same disease or their grandchildren are also having diabetes or hypertension. So they have the data. So that was the example of cohort study, Framingham Heart Study. Then cross-sectional study is a good tool to generate hypothesis. Yes, a cross-sectional study is used for generating hypotheses which can be subsequently tested by case control or cohort. There you establish causative relationship. Cross-sectional, what will you calculate? You calculate okay. Yes. However, cause and effect relationship cannot be established. Application of cross-sectional study to estimate prevalence, this I have discussed. Monitor trends over time. Yes, cross study is good tool to generate hypotheses which can be subsequently tested by a case control or cohort study. Now, prevalence of an event, you can calculate number of existing cases at that point of time, size of population. So, and this type of prevalence we calculate in cross-sectional, we call it point prevalence. Please remember, there are two types of prevalence, period prevalence and point prevalence. So if you are carrying cross-sectional study, if you are doing health checkup of school children or status of hypertension among 400 people, adult people, so you are going to measure only once everybody's hypertension. You may collect data for every Monday, you can collect data and thus you can complete sample size of 400 in a year. But then you can only calculate the point prevalence. You will calculate prevalence. Please remember, in cross-sectional study, you calculate only point prevalence, and this is the formula. So prevalence, it is the proportion of person in a population who have a particular disease or attribute at a specified point in time or over a specified period of time. For period of time, we calculate period prevalence. So in cohort study, you can calculate period prevalence, but here in cross-sectional, you will always calculate point prevalence. Now another study, cohort study. It is a prospective study. You follow a group of population for next 5 years or 10 years, where two cohorts similar in all aspects except the exposure of interest are followed over time to see if they develop some disease or if some event occurs. Actually, you take healthy people, those, suppose you want to see how many people develop cardiovascular disease, then you select 500 people, all healthy, without any disease, but you want to see effect of smoking on hypertension, how many people develop hypertension. So you will make a cohort where each person is a smoker. and you take suppose 200 people or 300 people, those who are smoker and age 20 to 25 years, and then you follow them for next 20 years or 30 years. And you take another group which is non-smoker and you follow them also. And after 20 years, again you do health checkup. Yeah, after every 5 years you do health checkup, and then you see how many of them develop disease, how many of them do not develop, and then you compare. The cohorts are sharing common characteristics. What is a cohort? Cohort, group of people sharing common characteristics, differ only in exposure of interest. Like common characteristics, those who are all males, those who are 20 to 25-year age group. So we can call it a cohort. All from urban area, all from rural area. That is one cohort. All are smoker. They will make one cohort. The smoker, then which is exposed. Another non-smoker, we call it unexposed subjects. And contract disease, they may contract disease, but at the time of selection, starting cohort study, everyone will be healthy with no disease. Only one group will be exposed group, another will be non-exposed. So both the groups are similar. In cohort study, we begin with disease-free individual. This is very important. Classify patients as exposed or unexposed. I will not use word patient. I will use word classify people as exposed and unexposed. I will make correction here. It is not patient, yes, because we do not have. Yes. Just I will make correction because I will share this slide with you. So classify person as exposed and exposed because they are disease free. Then follow up over time and record outcome in both groups. Some may in exposed, some may develop in unexposed, some may develop disease. But if cigarette smoking is the cause of hypertension, then in exposed, more number of cases will develop hypertension, and in unexposed, less number of cases will develop hypertension, because there may be another causes also, genetic causes. And we compare outcomes using suitable measure. Now measure I am going to discuss. Now see the diagram. We have taken exposed people, those who are smoker, and not exposed people in 2000. And we observed them till 2005 or more. Now here exposed group and not exposed, both are not suffering from any disease. But exposed, they all are, see, smoking. I have made these cigarettes. They are smoker, but they are not a smoker. After follow-up of some year, they are with outcome. Maybe suffering from bronchitis, maybe suffering from bronchiectasis, and they are without outcome. Here also some develop outcome and some do not develop any outcome. Okay, this is what is the end analysis in cohort group. So in your thesis at PhD level or MD level, what I suggest, if you come across a hypothesis where a disease can be developed in 6 months or a phenomena can be developed, like people say that the hypertension or diabetes can be controlled through yoga and meditation, suppose. And the result you may get after 6 months, suppose people say. So you can collect two groups of people, both are having hypertension or diabetes, and then in one group you expose them with yoga, and another group, and both group you give medicine treatment, another group you do not ask them for yoga. But there may be ethical problem. So if you make research design, so you say that for 6 months in the beginning, the exposed, they will undergo yoga and meditation. If they improve after 6 months, the same yoga meditation you will apply to non exposed people also, because they were not. So ethical clearance you can get. You must also say this thing, that for first 6 months, then you will cross, then another, the control will also be given exposure for the benefits. Otherwise, it will be difficult for you to get ethical clearance. Now measure used in cohort study, how you measure. we measure prevalence. Now here you can measure period prevalence, that in 10 year what happened, how many cases developed, 10-year duration. We call it period prevalence. And point prevalence you calculate. Here you can calculate point prevalence also, all new cases. Now new cases, because you are following then 10-year, 20-year, you can come across new cases and they will make incidents. It refers to the occurrence of new cases of the disease or new injury. And then you calculate incidence among exposed population and incident of an event in unexposed. Number of new cases divided by size of population. So you calculate incidence rate in exposed, incidence rate in unexposed. At this moment, I would like to ask my students, please read about incidence. Incidence can be measured into 3 ways. That is not my topic today, but I will touch it. That incidence, you can measure incidence risk, that is one. Incidence rate, that is second. And incidence time, that is PG level question, postgraduate level question. UG level we don't teach, we teach you only incidence rate. So incidence risk, that is probability, you calculate. Incidence rate, yes, with the rate disease is occurring. And incidence rate, you can also call it, it is a density type of indicator. Because in denominator we use person year, okay? But in incidence risk, we do not use person year, we only use total population in the beginning of the study. So kindly go through the literature, read how incidence risk is calculated, how incidence rate is calculated, and how incidence time is calculated. You can refer to modern epidemiology by Rothman, that is one. And you can refer to by Dr. Kleinbaum, the active EP, that is the book of epidemiology. And he's a biostatistician, but great epidemiologist from US. I have attended his lecture. Very interesting man. Usually the statistician, we are afraid of that their lectures, sometimes we close our ear and we do not listen to statistics lecture. But I would like to ask you all that statistics is really very important, very interesting. And Dr. Kleinbaum has made statistics very interesting. There are few teachers who have made statistics very interesting, very enjoyable. If you are very clear, only thing is, you may recall that during your studies, when you were in 10th, you were studying mathematics and you were all excellent. You were getting 100 out of 100 marks. But now in medical college, you are not taking interest in statistics, because the reason is only you do not practice it. If you come across daily some situation and you analyze, then I think you will not forget it. Only because once you read in a lecture and you do not revise it, do not read anywhere, so you are having that, you are afraid of the difficulty of statistics. Statistics will make epidemiology more interesting and more useful. So this is incidence you have calculated. Then we can calculate relative risk, okay, or relative risk. The formula is magnitude of association between exposure. Suppose if somebody asks you whether disease is associated or strength of the causation, strength of causation. So the chi-square test helps you only to get association. It never gives you that it is very highly significant, it means highly associated. And less significant means less associated. No. Whatever value of chi-square is, you only get answer association. But here relative risk gives you the magnitude of the causative relationship. So if you have to measure effect of disease, you can measure effect of disease only by calculating relative risk or attributable risk. There are two things, effect and impact. And in your research design, you will only calculate effect. Impact you calculate at population level. So I am talking of that you can calculate effect of cigarette smoking. You will calculate relative risk. Only then you can say that among the smoker, it is 5 times more common. So you get magnitude of the problem. It indicates likelihood of developing disease in exposed group related to those who are not exposed. Relative risk is given by formula. The relative incidence rate in exposed divided by incidence rate in unexposed. In the same way, if you calculate incidence risk in exposed and you calculate incidence risk in unexposed, then you get relative risk. Whatever I am saying over here, relative risk, when you calculate. Park has mentioned about relative rate. So we call it relative risk. Relative rate you calculate when you calculate incidence rate in exposed and you calculate incidence rate in unexposed. So incidence in exposed, i.e. upon incidence in unexposed, IU. Formula becomes very easy. It measures the strength of association, which is important in causation and in policy prevention. Now, RR1 means 0, no effect of exposure. If you get relative risk of 1, you can interpret. Second, if it is more than 1, means positive effect of the exposure, means cigarette smoking. Suppose you get value 5, then you can say the cigarette smoking may lead to development of bronchitis or bronchiectasis or lung cancer 5 times more as compared to unexposed. So it is giving you effect of cigarette smoking, magnitude of the problem. Less than 1 means negative effect. It means if you get 0.3, 0.1, if somebody is smoking, then you can comment, yes, it is having preventive effect. Those who smoke will not suffer from lung cancer, will not suffer from bronchitis. But here, if you give vaccine, then you may get negative. Those who are vaccinated, those who may not suffer from disease. Those who are using mosquito net may suffer less frequently from malaria as compared to those who are exposed to mosquito will develop less cases of. Those who are not exposed to mosquito net will develop more cases. Then risk difference. So incidence risk, if you calculate, and then you can calculate attributable risk, means how much more. The absolute effect of exposure to or excess risk of disease in those exposed compared with those non-exposed. Sorry. So you get excess risk of disease. Suppose the incidence risk or incidence rate is 5 in exposed people who develop lung cancer, who develop no lung cancer in unexposed. In unexposed, if it is 1, in exposed, if it is 5, then you can say 5 minus 1 is equal to 4. It means if somebody smokes, then every time for number of smokers, like if you have sample size is 100, then you can say if 100 people smoke, then every time 4 more cases of lung cancer will be developed. 4 more cases, 4 cases in excess. Is that clear? It is given by incidence rate in exposed minus rate in unexposed. Or if you calculate incidence risk, then you write incidence risk in exposed minus incidence risk in unexposed. So incidence among exposed minus incidence among unexposed. 5 minus 1 is equal to 4. That is imaginative. Now attributable risk percent. This risk difference is also called as attributable risk. Now attributable risk can be converted into proportion. The formula is, it refers to percent of cases which can be attributed only to the exposure. Now the same number The attributable risk you can calculate into proportion by using this formula. Attributable risk percent means incidence among exposed minus incidence among unexposed divided by incidence among exposed. You get in percentage. Number needed to treat. This is another analysis. I think in my previous lectures, I was not using these things, but I because this time special mention was that how to measure it also. So I'm discussing number needed to treat. This is one analysis you can do. It refers to how many people you need to give a particular treatment in order to have positive effect on one person. How do we calculate? It is given by this calculation. Number needed to treat 1 upon attributable risk. In our case, it was 4. So I will say 1 by 4.25. So means how many people you need to give particular treatment in order to have positive effect on one person. Means how many people will be cured, where AR is the attributable risk. Negative NNT indicates the treatment has a harmful effect. A negative NNT is called number needed to harm. Here number needed to treat, here number needed to harm, which is the number of people that need to be exposed to a risk factor to have harmful effect on one person. Because if you are exposing 5 people or 10 people, then only one may get harmful effect. Many times people say, I have seen many smokers, but they do not develop lung cancer. Because number needed to harm may be less, but certainly there is a harmful effect. So number needed to treat, this is another way of analysis in cohort you can do. Limitation of cohort study is that it is time consuming. I've told you. Costly and lost of follow-up. Many people, if you are doing follow-up, then many people, they are left. After 5 years, they may lose interest or they are transferred from one place, or some people may die during follow-up in car accident or bus accident. Sometimes it is unethical in some situations. Requires large sample size, not possible for rare disease. Yes, if there is a rare disease, you cannot do cohort study. But if it is a rare exposure, you can do cohort study. Rare exposure, suppose asbestos sheet, exposure to asbestos sheet. Now for the rare disease, you have to go to factory where asbestos sheet is being used, and you can get all persons who are exposed to asbestos sheet, and then you can take another population. But it is possible. It is a rare exposure. I'm talking of exposure, not disease. So in cohort study, you can include rare exposure when it is carried out in some particular factory. Only then you can take sample from exposed population. And yes, I told you in cohort study that Framingham Heart study, they are still carrying out. And you will be surprised to know that the term risk factor was generated during this study, because the risk factor which we are using very frequently, this term is a, you should say, boon of Framingham Heart study. During this study, they coined this new word. The study showed the role of healthy diet and exercise to reduce cardiovascular disease. Risk factor for dementia is being studied in this study. They have so many data. Now, because some elderly people are developing dementia, so they are using the same data. This study has amassed vast and the DNA library amounting around 5,000 individuals, 2 generations of participation. So it is over. Now, third one, case control study. I have covered cross-sectional, cohort study, and then case control study. It is a retrospective study in which 2 existing groups differing in outcome are identified and compared on the basis of some supposed causal attribute. I will give more examples. They are often to identify factors that may contribute to medical conditions. Suppose lung cancer. Now here in case control, In cohort, you have taken all healthy persons, whether exposed or not exposed. Only exposure was there, cigarette smoking. But in case control, you take cases of lung disease. And control, you take those who are not suffering from lung disease. So cases, but now you take retrospective study and you take whether how many of them were a smoker among lung cancer patients and how many of them smoker among other diseases. You may find that a majority of patients were a smoker in lung cases and very few people were a smoker in other diseases. And then you relate that the presence of risk factor in cohort, when you do relative risk, you say the risk of development of disease. In case control, please be careful for interpretation. You interpret and you say the exposure of the risk factor or the presence of risk factor is 5 times more or 5 times less. So you never say the disease occurrence, because occurrence you take in cohort study. In case control, disease has already occurred. Now only you take retrospective study and you try to find out how the risk factor was present in how many of people. So useful for rare, yes. If there is a rare disease, you are having 5-10 people, rare cases, you can take case control study. For one case, you can take 5 control. That is a chapter of sample size that they will discuss. 1:1 ratio, 1:2. For one case, you can have 1 control. For one case, you can have 5 control. By increasing control, because cases you cannot increase, cases you are having very less for rare disease, then you have to increase control, and that increases mathematical power, statistical power of the study. So that is mathematical things that will be discussed separately by in different lectures. So for rare disease, for rare outcome, in a case control study, you start with people who have disease. Please remember, in cohort, we started with healthy individual, and then we match them for the control who have no disease. If cases belongs to 40 year to 42 year, then you take control who is between 40 to 45. You can keep a range of 5 year, or it is better not to keep 20-year age variation. You keep 5 years. So closely, if the patient is 42 year, you may get control 43 year, it is okay. And you mention in your study that you will keep control within the range of plus minus 5 years. Okay. And you look back and you access exposure. I'm telling you, I told you also that you study exposure. Now you start, you are here. Okay, you are here. These are the cases and these are control. Now then you take past history. How many were exposed to one particular factor? And here, how many were exposed to one particular factor? So in case control, you start from current situation, you take past history. Measures of case control study, we calculate odds ratio. Odds is a measure of association which quantifies the relationship. You may remember we calculated relative risk. So relative risk you cannot calculate because you cannot calculate directly incidence of disease. We have already cases, we have calculated exposure. So the mathematically statisticians have devised a methodology where you get the estimate of risk by calculating odds ratio. I will explain how odds ratio is calculated. Represent odds that an outcome will occur given a particular exposure compared to the odds of the outcome occurring in the absence of that exposure. Odds ratio is calculated, odds ratio A into D, B into C. I will explain where A is number of persons with disease with exposure of interest. Number of persons without disease but with exposure of interest. So A and B, you have divided exposure of interest with disease, without disease. Suppose A by B. And the same is C, number of persons with disease but without exposure of interest. C, number of persons without disease without exposure of interest. I will take another slide and I will explain. You see here, the disease, exposed, unexposed, A and C, and no disease, B and D. B are exposed. So what is odds ratio? Odds that a case was exposed. You calculate by odds that a case was exposed. A by C, that you understand. Odds that a case was not exposed, directly B by D. So AC divided by B by D. Then you resolve it and then you will get this. A upon C multiplied by D upon B. You will take up and then it will reverse. So you get AD upon BC. And in my previous slide, I wrote AD upon BC. Here I have tried to explain. Now, odds ratio, 1 means 0, no effect of exposure. If odds ratio is more than 1, it means there is a risk factor, there is an effect of exposure. Means I will say the exposure was present. And less than 1 means it is a preventive factor for that disease. Limitation of case control study. Cannot determine incidence or prevalence in case control. I told you, because disease occurrence you do not see. You take retrospective study. So you cannot calculate risk difference. You cannot calculate risk ratio. Faces recall biases. If a diseased person is not yet diagnosed with disease and kept in control, it may affect study finding. That is one bias can occur. Not suitable for rare exposure. For rare exposure, we can do cohort study. I told you, I gave you example of asbestos. Rare exposure, you go to factory where asbestos is used. So you can do cohort study. For rare disease, you cannot do cohort study, but you can do case control study. Now some biases in the last. Memory recall may take place. Selection bias. At the time of selection, you have to be very careful. Then confounding bias, proper matching may reduce this bias. I told you that age group plus minus 5. Parkinsonian bias, this is different rate of admission. If you know that few people, they come hospital, if you are taking from hospital this sample size, so there are people who prefer to go hospital after taking some lunch at 11 or 12, and then they go to hospital. And few people, they do not want to take lunch, they just want to go early in the hospital. So that is their habit. So you can miss a particular type of cases. If people have if patients who are lung cancer, they prefer only going hospital after lunch or around 1 p.m. Then if you conduct survey from 9 to 10, you will miss all those lung cases. Such bias, we call it Parkinsonian bias. And interviewer bias, your bias, you taking interview. So my talk is over. Over to Amit.
Thank you, sir. Thank you so much for delivering the most important topics of and initiating the study design. So all delegates, if having any doubt regarding these two sessions, fundamental of study design and observational study design is a major. So you can clarify your doubts here. You can write in the chat box. You can unmute yourself.
Or they can write you and I can answer them separately.
Definitely.
I've taken a lot of time, perhaps people are tired.
No problem, sir. No problem. Yes, no problem. Really honored to hear you in our all programs. And we are open 1 minute more. If having any doubt, you can write us. Right now, you can unmute yourself. Thank you, Dr. Kritika wrote that thanks a lot, sir. It was indeed the best lecture I have attended till date.
Okay, book.
Good evening, sir.
Somebody has
This is
asked
Dr.
me book. Book one, I will suggest that I will give reference to Amit. Okay, I will
Yes,
write
yes. I will.
three
I will
books, very
share.
good books. One was by Dr. Kleinbaum, Active EP, ACTIVE, Active EPI, Active EP,
I will
and
share link also.
so I will write it, and then you can share. That will be
Yes,
better, because
definitely.
if I say
Definitely.
there are 2, 3 books, Leon Gordis is another book, good book, people may enjoy. But certainly Park may not give so many answers. Leon Gordis may give them for those who are researcher.
Dr. Nelia Thachi wrote a query that what is nested case control?
Yes, hybrid, because this lecture will
Yeah,
be
yeah.
taken on later on.
You will learn this the day after tomorrow. As
Uh,
tomorrow there is an interventional study, then it comes under the hybrid study design. So
Hybrid study design.
it will be
Yes.
discussed in further sessions. Uh,
Hello,
and
good evening, sir. Actually, I want to know that when we are doing the survey study from a population, so how we can draw a population sample from a given population. So, is there any formula to derive that
Uh,
particular sample
Amit,
in a population?
okay. Just wait. Amit,
yes,
are we
Doctor,
taking separate lecture on
yeah,
sampling?
Dr. Nan Kishore, after study design, there are 4 lectures on sampling
Good. So,
specified. So
Okay, sir.
all
Sir.
sampling queries will be uh, discussed very brief, because we assign 4 lectures on sampling this
uh,
time. So
Okay, no
definitely
problem.
we'll
Thank you.
get
there are different formulas, different methods. People use
as per
PQ
the
upon
study.
L square. But I think that lecture will be better. That will enlighten you more for the sample size. So there are standard method. And for researchers, I think they must follow standard method of sampling. So after the
Definitely,
4 lectures, I wish and I am confident that they will, I think, learn the lecture.
definitely, sir. So thank you everyone for your patience, continuously hearing the both sessions in a single day. Thank you everyone. Thank you so much, sir. On the behalf of organizer,
Acha,
we
there is one question about
yeah,
population attributable risk,
yes,
because
yes.
I told you that either we measure effect or we measure impact. For measuring effect, I told you that we use risk ratio, risk difference, and for measuring impact, we calculate that population attributable risk. Okay, so that can be taken. It is again 1 hour lecture. Measurement of impact separate 1 hour lecture. Measurement effect another 1 hour lecture. So you can refer to measurement of impact. Usually when you do sampling, then we cannot calculate impact. We only calculate measurement of effect. And I have discussed those by calculating cohort study. By doing cohort study, you can calculate measurement of effect, that I discussed with you. But measurement impact, I have not discussed. So you can refer to how to measure impact. I think separate 1 hour lecture. Yes.
Definitely, Dr. Harshad, I hope you get the answer, and it will be covered in our advanced program. When we initiate our 2 month advanced program, then we again come with advanced topics. After that, after this program, definitely we come with the advanced topics,
But
so
I'm
you can
happy
get
that
more deep.
students, they are asking
Yes.
such questions which we are going to cover later on. They are asking in
Somewhat
advance. Good.
definitely, sir. Dr. Pooja Ambu wrote a query that, sir, confounding factor.
So confounding factor, I think, again, if you are taking a separate lecture on confounding factors only, it will be very good in statistics. But confounding factor we can reduce to some extent through matching. I told you about age matching or some disease. Matching means usually we go for age and gender matching. If cancer patient of lung is male, then you take control also male, because there are various hormones. They also interplay. They may act as a confounding factor if you change the sex. So you can reduce the confounding effect. Confounding factors are those factors which you do not take into consideration, but they interfere in your observation. So they interfere in your result. That is in short, I can say.
So I hope, Dr. Pooja, you get your answer. So thank you all delegates again for a wonderful queries, discussing your doubts with sir. And thank you, sir, for honoring us, for sharing your expertise in this program, in 3 month certificate program. On the behalf of organizer, we convey our sincere thanks for your presence for your valuable time and your expertise sharing with all delegates in this program. Thank you, sir. Thank you so much.
Okay.
So all delegates, this is the end of today's session, and tomorrow we will start at 6 p.m. sharp with another scheduled session, that is interventional study design and its measure. So be on time. Tomorrow's session will start as scheduled at 6 p.m. Thank you everyone. This is the end of today's session. Thank you so much, sir.
Thank you.